First thing that we're going to talk about today is two common bases. So yesterday we talked about base 2, base 4, base 10, and we had all kinds of different bases that we were working with. Your calculator, though, only has two. And the names of those two, the first one is the common log, and the second one is the natural log. So the first one, if you have log base 10, typically they're going to get rid of the 10 and they're just going to write it like this. And if you see a log without a base, you automatically assume that it's base 10. Okay, see a log without a base, it's automatically base 10. If you see this ln, which doesn't really look like a log at all, that is a log, but it's log base e. It's log base e. Okay, and what did e stand for again? Oh, you're close. Positive 2.718. That was that number that we talked about in 7.3. We're going to end up seeing that quite a bit coming up. So your calculator has both of these bases. All right, so we're going to do a little bit of work with that. So let's start here. Log of 8. Now don't grab your calculator quite yet. Let's just think about this. So log of 8 is how you would say that. That is log base 10 of 8. That means the same thing. And we're trying to figure out what it's equal to. So if I rewrote that in exponential, that would be 10 to some power equals 8. Now, we probably can't do this one without a calculator, but I want you to think about what kind of number that exponent is going to be. Would it end up being a negative? Would it end up being a positive number greater than 1? Or would it end up being a positive number between 0 and 1? What do you think? Okay, ideas. What are we thinking? Between 0 and 1. Why? It's getting small, but it's not really small. It's not like a decimal small or a fraction small, right? So it's going to be probably, we're thinking between 0 and 1. Would you guys agree with that? Okay, so let's check it out. Grab your calculator. And find log on your calculator, which is right here. And you're going to plug in log 8. You don't need to worry about that 10 at all. If you just do log 8, it's assuming base 10. And we were right. It is a number between 0 and 1. So let's just be sure that that really is our exponent. What if we do 10 to that power? Should be 8. Check it out. And it is 8. Okay? So there will be problems like this on your homework, and it is just strictly a calculator problem. You don't have to do this piece right here. That's not a requirement. I'm not going to be looking for the work on that, but it's a good idea to think about why your calculator is giving you the answer that it's giving you. All right? Let's do the other one. So ln of 0.3, what's ln again? Log base. Okay, don't put it in your calculator yet. Stop punching in. Let's think about this one before we go on. Log base e of 0.3 equals what? And that means that e to the some power equals 0.3. And e was what again? 2.718 to some power equals 0.3. You decide on your own right now, before you put it in your calculator, what do you think? Is it going to be positive, bigger than 1, between 0 and 1, or negative? And then check it out. Plug it in your calculator and decide if you were right. ln is right below log. And it is a negative, were you right? Okay. So going with Terrence thinking before, it's making it smaller like the last one, but it's making it really small, right? Like fraction type small, and which is why we have a negative there. So the book rounds to the nearest 3 decimal places every time, so I'm going to ask you guys to do that for logs as well. So we'll do negative 1.204. The second part of this chunk of 7.4 is going to be based on 2 properties. And these 2 that you see right here. I'm not going to prove these to you. They are a little bit tricky, but if you want to see the proof, it just goes back to the definition of log, and I can definitely show that to you. The idea behind this is if you have the same base in your power as you do in your log, that all cancels each other out. And all you're left then with is x. So that whole thing is equal to x. Okay, similar is true if you have a log of a power and you have the same base on your log as you do on the power, then again that cancels out and you're left with just x. Okay, so let's look at a couple examples. So for both of these, I don't see a base at all. So I don't know. Do they cancel or not? I'm not sure. Well, we just talked about ln, right? How else could I write ln? Log base e, right? So this is e to the log base e of 20. That's just another way to write ln of 20. And now you can see that the e and the e, those match. So this whole thing right here, that all cancels out. And that is just equal to 20. Now we have e and we have ln in our calculator, so we can check this out and make sure that it's right. So let's do e to the ln of 20. You guys try it on your calculator. Okay, and we do get 20 there, so that proves to us that this property really does work. Let's try the other one. This log right here, again, doesn't have a base. So that one's not base e like the other one was. What is this one? Base 10, right? Anytime it doesn't have a base but it says log, it's base 10. So 10 to the log base 10 of 4. Again, same bases, cancels, answer is 4. You try it on your calculator and prove to yourself that that's true. Okay, let's look at the last 2. So these both do have bases. First one is base 2, second one is base 5. But the same thing isn't true because I don't have the same base in my log as my power. So I can't cancel anything out. But I can rewrite this. Let's rewrite this as log base 2. And instead of putting in 64, I'm going to put in something that equals 64. So 64 in a different form. And I want my 2's to match up, so I want that to be a 2. And I can write 64 as 2 to some power. Just think about it. Don't say anything. Think through 2 to the 6th, right, is 64. And so now I have the same basis. Same base in my log as base in my power. So we get really excited and we cancel that out and it's gone and my answer is 6 to the x. But that's not actually right. Okay, so before I cancel all that out, let's think about this for a second. What if I have an exponent to an exponent like that? You multiply. Let me give you an example. Like if I had 2 to the 3rd to the 4th, that's really 2 to the 12th. right? And so this is really log base 2 of 2 to the 6x. And so that whole thing cancels, and my answer is 6x. Yep. You guys try the other one. Okay, so I want a number that equals 25, another way to write 25. So I can write it as 5 squared. And then this whole thing is really 5 to the 2x, which is equal to 2x. Questions? I can go through that definition with you. Like I said, that's just proving that property. So if you want me to do that, I can. Lastly, and you might want to add a page onto your notes right now. Remember, you can go back up so that your pages show up on the right-hand side, and then you can add in. Ask your neighbors how to do it if you're not sure. We're going to do a challenge problem because there are a couple of these on the homework, and I just want to give you a taste of what these look like. Okay, so your goal is to answer this one. Now you can use that property that we just talked about, but it'd probably be easier going back to what we did yesterday with just rewriting this in exponential form. So 125 to what power is 625? And you're probably going to want to use your calculator on this. It's up to you. But this is a challenge problem, right? So your answer is not going to probably look like any of the ones that you had yesterday. So try to figure this one out. So I know a couple of you have figured it out, and I don't want you to spend a ton of time punching in numbers. We don't want to waste our time doing that. So let's think through. We already said that it has to be a number between 1 and 2. Okay, and I gave you the hint to think fractions. So if it's a fraction is the same as, if a fraction is in the exponent, it's the same as a root, right? Like to the 1/3 power would be the 3rd root. So the 1/4 power would be the 4th root, right? So think about 125, and without using your calculator, can you figure out in your head what the square root of 125 is? I don't know it. I don't know if you guys do. I know the square root of 144 and the square root of 121, but I don't know the square root of 125. What about cube root? Cube root is 5. 5 times 5 times 5 equals 125, right? So let's start there. Maybe that'll help us. I'm going to take 125 to the 1/3 power, which is the cube root. And that, you guys just told me, is 5, right? Well, what about 5 then? Can we take 5 to an exponent to get 625? 5 to the 4th. Okay, do it in your head. 5 times 5 is 25. Times 5 is 125. Times 5 is 625. So 5 to the 4th is equal to 625. Well, this right here is equal to 5 as well. So if I take that to the 4th, that is also equal to 625. Okay, you guys try it in your calculator right now. Prove to yourself that this is true. Do 125 to the 1/3. Okay, remember you have to use parentheses around your 1/3. And then take that number to the 4th. Does it work? Okay, but we want to simplify. So you told me before that if I have an exponent to an exponent, I do this. I multiply. So 1/3 times 4 is 4/3. Try this in your calculator. Is 125 to the 4/3 625? And so the answer to our question then would be 4/3. And there will be 2 challenge problems like that on your homework. Okay, so look back if you're not 100% sure to those problems.